potential energy. So in this lab, the purpose is to show the relationship between kinetic and electric potential energies when two magnets are attracted to each other. I looked at the observed position, which was a real-life simulation made through Tracker and an online video, and I predicted the position through an online computational model. So the lab intro continued. Some models and fundamental principles used were first Newton's second law. And this law in this specific lab, as told at the bottom, was that the F net, the total force, would be the electric force. Also, the energy principle is important here because a system's change in energy is equal to the change in energy of its surroundings, and no energy created or destroyed only can be transformed or transferred. So we see this when we see that E is equal to K plus UE, the electric potential energy. So overall, the brief preview of the main results from Lab 5 is that we will see that each of the potential energy components add to be negative in the beginning since the system is bounded. And this proves the energy principle to be true in action because the kinetic potential energy will go to zero when the magnets meet, and theoretically, the electric potential energy would move to zero. So different potential energy formulas I used here and my reasoning for using them. Well, first is the electric potential energy formula, and as seen, I use this because this lab is mainly about the electric potential energy between two magnets and also the kinetic energy. I use this because, as you'll see in the video, the two magnets are attracted to each other, so there's movement involved, and they're moving. So some assumptions. You may have an assumption that the addition of each of the potential energies will be negative since the system is bounded and attracted to each other, and also the electric potential energy will transform to kinetic energy because they move. So the system in this model will be the magnets, and the surroundings will be nothing. There's no applied forces. So some initial conditions, well, the initial velocity is 0 since they move from rest, and the position is seen here through Tracker. It's right there. So the details of the experiment. Well, first, I recorded the video of the attracting magnets taken from YouTube. Then I took the video to Tracker, where I observed the location of the center of mass at different timestamps intrinsic to Tracker. Then I used GlowScript to create a computational model of two magnets and used their potential energy formulas to equal the total change in energy. And after that, I took it to Google Sheets to insert my Tracker X and Y data. And last, I used this CSV file from Google Sheets for the X and Y data to compare these Tracker values with the computational changes in energy. So, the observed version through Tracker is seen in this video. This is the video I used off of YouTube. Awesome. And you can see the X and Y components on the side. So, the GlowScript code. Here is where I input the initial values of the position and velocity and the system energies to get the total energy as seen at the very bottom. There's K plus UE, and E would be K plus UE. Each of the potential energy formulas are also listed here through this code, and right here is where I calculated the velocity for kinetic potential energy because velocity is included in that formula, and also where I found the changes in electric potential energy and the kinetic potential energy to get the final change in total energy. So yes, Q1 and Q2 would be two different signs because they're opposites. So overall, some results. The experimental model predicted the X position to not change, which was strange, but however, the computational model proves that the X coordinates do in fact change because they're moving towards each other, so there is movement. Also, the Y position behavior was similar for both the computational and experimental models in the fact that Y doesn't change, which is accurate for this. Possible sources of error. Well, some of the markings of the center of mass in the middle of the magnet may be slightly off, but really, the GlowScript code was so hard to navigate, and the outcome from the experimental data may be off because of the surprising results that we just saw for X. However, the computational model shows that the electric potential energy made the magnet move towards the other. Yes, unfortunately, I'm not a CS major, but I tried my best. Also, so for what does it mean? Is the energy principle satisfied? Yes, the potential energy transforms to kinetic energy and the total energy is negative until they meet at the middle where K reaches 0. If I tracked the other magnet, would the graph look any different? No, it would not look any different because opposites attract and would still be bounded.